So when we last were on this, we ended, hopefully, with a game, in air quotes, where you could start a host and you could fly your ship backwards and forwards, and these beautiful enemies over there were spawning. Perhaps not the most engaging game so far, but hey, at the very least, there's input. What we're going to be working on today is being able to shoot lasers to destroy those enemies and to be able to add a score overlay on top of this. It will not be a full featured game, but to be able to see all the working pieces allows you to then build up to those full features if you're interested in doing so. So let's work with the shooting next because we can't have a score without shooting. And to get to the shooting, we are going to go into our scripts folder here. And we are going to make a new script. So I'm going to go to create C# script, and I'm going to call this shit a C# script laser. It made it too fast for me, I think, which is very frustrating. So I'm going to have to go through some renaming thing here in a second. I'm finding Unity working much slower. So you're going to see actually what happens if you don't name it correctly. So I'm going to name it laser, and I'm going to go ahead and open it up inside of Visual Studio. And then inside of Visual Studio, you'll see that my laser is actually not called laser, it's called new behavior script. This class name here has to be named the exact same as the file. So if it's named laser down there, it must be named laser up there. So we've now made a laser script. This one's actually going to look rather familiar to us if we've been compared to what we ended with, because the base of it is going to look very much like the player ship. So inside of laser, we are going to import Fusion because just in case this is going to be network, and I'm going to assume it's network. So using Fusion, every time I think about Dragon Ball Z, that means we're going to change this into a network behavior. And then we are going to make two variables, properties of this class. The first one will be a public space float space speed. So how fast does this laser go? And then the second will be public space, or not public, good grief. We're going to do a private rigid body. And I always call that RB. If I have that private rigid body RB, I'm always going to set it here in the start. So equals this dot get component, rigid body. And so we're going to get that. And then immediately we're going to sort of kick it off, just like with our spaceship. So RB dot, I don't like that. RB dot add force. We're going to kick it off in the forward. So this dot transform dot forward times, so what way is it facing, times the speed that we specified. So this should be pretty familiar to us. It should look relatively like our spaceship. But we're going to add some more things. In fact, let's go ahead and add the first one while we're in the code already. So I'm going to get rid of update. We're not going to need it. I'm going to make a public space void on trigger enter. And it's auto-completing for me. It might not auto-complete for you, but this is the typical naming scheme for it. You name it collider other. Awesome. Now we're going to return to this in a second, but let's go back and make our laser prefab. So save that, come back to Unity and let that compile. Let it do its thing. And then once it's done its thing, we're going to go and make a new empty game object and name it laser. I like to just make sure that its position is at world center, so I'm going to set it to 0, 0, 0. In this case, there's that big icon there, so I'm actually going to move it maybe just a little bit further away. And then as a child of it, so I'm going to go to here and right click on it, or I can also go to game object. And I'm going to go to 3D object. I'm going to make a plane or a quad will both work. I'm going to make a plane. Ooh, you're kind of big. Let's see what a quad looks like. Oh, was that 3D object quad? Quad looks a little bit nicer. I'm digging the quad. I'm going to world center that. Also, I'm going to put that inside of laser. And then once it's in laser, I'm going to once again center it so it's there. Now this is going to look a little bit weird here, but I've always just sort of played with it. We want to actually rotate this, so its rotation X is 90 degrees, so it's actually facing down from us. Ideally, I would find a material that's double-sided, but I'm not going to in this case, so I'm just going to sort of BS my way through it. And I'm going to scale it so it's a little bit more laser shaped, so something like this. So there's going to be our laser graphic. I don't particularly like this look for a laser. It looks like a steel beam that we're shooting out, and I'd rather make it look sort of beam. So I'm going to return to our root assets folder. I'm going to make a new folder. So right click, create folder. I'm going to name this folder materials. I'm going to enter into the materials folder here. And I'm going to right click inside of materials. I'm going to go to create. I'm going to make a new material, wherever the hell that is. New material. We'll call this laser material. Beautiful. With that selected, I'm going to drag that material onto there, and you'll see that it's changing the color for me, so it's clear that we've applied that. But as we keep this selected in the materials, let's make it feel a little bit more lasery. We could change this base map here to something else, right? Sort of this. And if we were working inside of here, in fact, what I would probably do is hit emission and have it actually emit. Because that's where you get sort of the strong, if we put a dark, like reduce the light or anything like that, it's still going to be emitting color from it. But for now, I'm actually going to go find another material type. So I want for you to find something that looks particly, either under the universal render pipeline. I think they have particles here, particles folder, lit, simple lit, or unlit, or based on yours, you might have another one that's a particles. I'm going to do a simple lit for this one, and that's going to swap it for a second. And it's actually going to keep a lot of what I have, but what I like about this that may or may not be apparent here, let's see if I can't just get a game object beneath there, 3D object cube. Wow, this thing is taking sweet time. Beautiful. So I'm going to put a cube beneath there, and then I'm going to select my material again. And the color mode right now is multiply, and the rendering type is opaque. So if we change this opaque to transparent, and we let it compile, and then we go to our base map and we crank down that alpha, you'll see that this becomes sort of see-through, and that might be a little bit closer to what we're looking for a laser. So that feels a little bit better for me. And rather than a multiply, I think I'd rather an additive or an overlay, something that brightens rather than darkens. Um, I'm going to go with overlay and see, it's going to be fine for what we're working on. So now we have this laser with the quad, that's the visual element on it. We don't actually have that laser script attached to it, so let's go click on laser. We're going to go click on add component. We're going to type in laser. We're going to do that. Because it's a thing, we're going to do an add network object. And in fact, I'm also going to add a network transform to it, which means it's going to need interpolation target. So we're going to right click on laser. We're going to go to create empty intr target. Awesome. And then drag and drop that on there. So now we've customized this laser to be the game that we're working on. Well, that statement didn't make any sense, but we've customized this laser to be something that exists inside of our network system. It's got many of the things that we need, but it's actually lacking too. So actually, I'm going to remove component. Why did I do that? I'm going to select this laser. I'm going to add a rigid body. So I'm going to add a rigid body. I'm going to turn off that gravity. Beautiful. I'm also going to, with that laser selected, add a box collider. And with this box collider selected, I'm going to hit is trigger, and then I'm going to modify its shape. So I'm going to hit this edit collider button way down here, and I'm going to modify it just a little bit. It doesn't have to be all that precise. We can make a relatively forgiving game if we wanted to, but this will represent the part where the laser can hit things. So this is actually what we're going to represent as a hit box for that laser. So there that is. Make sure it's set as trigger, and then the last thing I'm going to do is a network rigid body, make it a little bit smoother, and then set that interpolation target again for that. That should be everything that we need for our laser for now. But because I want to spawn these lasers rather than rather than just have one existing on the screen at the start. I'm going to go open up my prefabs folder in my root folder, and I'm going to drag laser into my prefabs folder to turn that into a prefab, and I can delete that laser now. It can go. With that laser deleted, we can now go back to our script. Do I want to go back to our script? No, we're going to go to a different script for a second, actually. So I guess I'll let that compile. But with that laser deleted, we're actually going to go to our player script. So I'm going to go to Assets. I'm going to go to Scripts. I'm going to find the player ship. And I'm going to open up that script. And we're going to go into the fixed network update. So far, what we've done is we said, hey, get this input. If it exists, we know we want to move this particular player, and then do this move. So now we're going to do the stuff for shooting. So here would be the elements for shooting. And what we're going to do here is we want to know, we don't want to shoot every single frame a button is pressed. In the design that I have, we want to shoot when the button is pressed on the single frame that's pressed. So there are ways to do this, but this is one of the easier ways to do it. To know the frame when things are pressed, we actually need to do something a little bit wild here. We're going to make a new variable. Var pressed is equal to input dot buttons. Again, input is the stuff that we're getting from the user if we are allowed to control this thing. So input dot buttons dot get pressed buttons previous. Okay, this gets a little bit weird. I don't know why I have those two. I want to see if I can get away with one. So this doesn't exist yet, this variable here. We're going to make that variable up here at the very top. We're going to add a buttons previous. It's going to be a networked thing, so it's going to be shared across all computers. Because it's networked, we have to add these network tag at the very top. And then we're going to make a public space network buttons space buttons previous. And because it's network, we need a getter and setter. So we're going to do a get, comma, set or not comma, colon, set. So this is going to store the previous state of the buttons for us. So we can compare the previous frame to the current frame and tell ourselves is a new button pressed or not. Now I misspelled this down here because I did a capital button. Well, let's just do a lowercase buttons previous here. That makes more sense to me anyway. So lowercase buttons previous there, so that is correct there. So buttons previous. That's going to get our compute pressed / released state. And then we're going to store this state as the previous state. So we need to remember what was the last state so we can compare again. So this is how we remember, like 1 second ago you weren't pressing a button, now you were, so I'm going to assume this is the moment you press that button. So buttons previous is equal to input dot buttons. This is just how you go about doing this. Apparently in the code that I wrote last time I did this, I did a lowercase rather than uppercase, which is interesting. Next we check to see if the fire button is pressed. If press dot is set space input dot fire. So if that's set space input dot fire, then we are going to fire a laser, and I'm going to go ahead and make a new method for this. So fire laser. So this is the shooting stuff here. We actually need to remember what was the buttons that people were pressing on the previous update, the last frame. what are the buttons that you're pressing right now, and then, or sorry, what is sort of the state? Have buttons currently been released or unreleased, and then if so, we're going to say that one has been pressed. It's kind of a weird workflow. I'm not the biggest fan of it, but so it goes, I suppose. Now this method here doesn't yet exist, the fire laser method, so let's go ahead and make that method. So down beneath there, we are going to make this could be a private void too, but I'm going to make it public void fire laser. And then once we save that, that will make that happy. And to be able to fire a laser, we need to know what the laser is. We're going to add a new component to this. So we have our public network buttons. We're also going to make a public space. What did I call this? Game object. Not handheld. What the hell is a handheld? Game object. See something new every day, huh? Laser prefab. So this is going to tell us, this is going to be the thing that we want to shoot from our ship. And while we're up here, let's go ahead and do a second one as well. We're going to do a public space, a public space transform, which is a position, space laser fire position. We're going to do this one so we know where to shoot this laser from. If we didn't do this, the laser would just shoot from the center of the ship, which may or may not be what we want it to do. So we're going to have the capability to set where that laser files from. Now that we've done that, we can come back down to fire laser and we can spawn a new laser. So runner.spawn. And by the way, as I'm working on this, this is honestly the least performant way to do it. We really should be using something called a object pool, but I don't want to make things too complex for you all. So if you're looking for ways to optimize this, I would recommend that you learn object pooling in Unity/Photon/Phaser. So we're going to spawn that laser prefab where our laser fire position is, and we're just going to have it sort of spawn facing up. So quaternion.identity. That's going to get us set and ready to go here. So we've added the capability to see what were my previous buttons pressed to figure out what are my current buttons pressed. Remembering the previous button press, if our current buttons press is the fire, we're going to shoot the laser. And if we do that, we're going to spawn whatever we tell it to spawn, wherever we tell it to spawn. Awesome. So we're going to come back to Unity and let that compile. Once that compiles, we are going to go to our prefabs. We're going to go find our player. And we are going to scroll down until we see our player ship object here, because there's two things that are lacking now, the laser prefab and the position. I'm going to go ahead and open up player first, actually. I'm going to right click on the player root element, and I'm going to create empty. I'm going to call this laser fire position. And this seems like it's forward for my ship, so maybe I want the laser to fire from there. Maybe it's even firing from like the left. Maybe it's doing something weird like that. So that's going to be the laser fire position. New element, empty game object, and I'm going to drag that onto the laser fire position there to set that. The second one here is the laser prefab. It needs to know about that, and I'm going to drag that prefab in from the prefabs folder onto here and save. Let's cross our fingers and go ahead and run this and see how it goes. We'll click Start Host. And I'm going to run back and forth. This one is hard-coded. Oh my god, they're moving so slowly. This one is hard-coded. I don't know if they're moving at all. To be spacebar for the fire button. So we see these running. And one thing that's actually going to affect this game, so I'm going to pause this right now and go into game and quickly into scene and quickly check. Go back to the actual game scene. So we want to make sure that the lasers are overlapping the enemies enough, and I think that they are. You want to make sure they're pretty dang close, if not like physically overlapping. So we made those. What are you unhappy about? I don't really care. Non-convex mesh collider. Something here must have a mesh collider, and I don't really care. Kind of blows me away that it's not merging those all. Cool. Um, okay, so now we're firing those things. We're sending them off. They're moving but very slowly, so I want to fix that. I'm going to go to laser. What is the default laser speed? Oh, 0. That's probably a problem. So let's try 30 and see what it looks like. That seems better. Life is a little bit slow, so maybe we're going to speed those up just a little bit more. Let's try 160. And I'm going to leave that one there for 160 on the laser prefab. We'll let that do that thing. But the next thing we want to do now is to go back to our laser script, because now we have the capability for that box collider, which is set to be a trigger to actually call and run when trigger enters. So let's go back to laser, and we're going to fill this out. Let's start with the if statement that you're going to see in a lot of these. We're going to write if other, which is the thing that it just collided with, dot game object. Well, that's the thing it just collided out. Dot compare tag. Does it have the tag of enemy? Now we haven't put this tag in our game yet, I'm fairly certain. So before I continue with this, I'm going to save and I'm going to return to Unity and I'm going to let that compile again. Ugh, Unity gets slower every year, huh? So I'm going to let that compile again. I'm going to go find my enemy. Oh, it did. It is tagged as enemy. Make sure you have it tagged as enemy. Very important for the coming stuff. So that's tagged as enemy. We went through that last video clearly. So if it's tagged as enemy, just in case this collides with things that are not enemies, we don't want to respond to that. But if it's tagged as an enemy, we're going to despawn both of these objects. So runner.despawn, or destroy both these objects. Other.gameObject.getComponent network object. Why is this so mad about? There we go. And we're going to write comma true. I forget what that does for us. Just put true. Very important. Must have true. um, I'm sure there's a reason why I put that there, but I actually can't remember what the true is for. Beneath there, we're going to write runner.despawn other.gameObject, or sorry, good grief, this.getComponent network object, open and close parentheses, true. So the thing that you send to despawn is not a game object, but a network object attached to game objects. So that's why I have to do this. Another caveat, it's very important that it comes in this order. If you destroy this first before destroying the other thing, it won't have the capability to destroy the enemy. Great, so let's save that. We'll come back and we're going to run that again. And when we run it, we hope that we see beautiful, beautiful deaths of the enemies. No. Hmm. Do my enemies have colliders? No, they don't. That would be a problem. My enemy doesn't have a collider. It needs a collider for this to work. So we're going to go to enemy. We're going to add a component. We're going to add box collider. Ooh, we're also going to find that model, which is weirdly offset, and we're going to center it in the enemy. That should be better. Beautiful. And so the box collider should represent it pretty well. I'm going to edit that box collider just a bit to be a little bit better at representing it, and also maybe a bit more forgiving as well. Beautiful. Let's try that. Because I moved that thing over, there's a chance actually that my lasers won't overlap. We'll see here in a second. We'll hope that it still works though. We're going to fire some lasers. We're going to hope that things are good. Yes. All right. So lasers go. Enemies go. Wonderful. There's actually another memory leak that happens in here too, where we don't clean up the lasers or the enemies. My recommendation is ask me in class how to fix that, because I don't think I'm going to have time to show you in this particular video. So next we're going to go to make a score. So we just want a score to count up as we're going here. And I want the score to exist in the screen space. At least I think I do. Oh, that's the wrong unity. There we go. So we want we want the score to exist as a UI element. And so I'm going to do that by going to back to our scene, of course, and I'm going to go to game object, down to UI, and I'm going to just add a canvas for now. So I'm going to do game object UI canvas, and this is going to be the stuff that's on our screen. And then inside of the canvas, I'm going to add a text object. So select canvas, go to game object UI, and we are going to do text, wherever text is, text, text, text. If this is your first time doing this, which it thankfully is for me, and we're working with this version of Unity, you're going to have to import Text Mesh Pro. So import Text Mesh Pro Essentials. So we'll take a second. Once it imports Text Mesh Pro, you actually don't need to import those other things. You just need that initial import. And if I haven't mentioned this before, sometimes I do, sometimes I don't, depending on the order of introductions in a class. The screen space is different than the world space. So here I am in my world space. Let me just quickly add a cube for reference. So here's my world space. That's my screen space. It's sort of a different space. So I'm going to go up to the screen space to work in it for a second. And the way that you get up there is by double clicking on the canvas itself to sort of make that full screen, and then hitting the 2D button to go into 2 dimensions. This will represent your screen. Another important thing maybe to consider is if we go to game, right now I have the game set to free aspect, which is just fine for what I'm working in, but oftentimes when you're branding a game, it might make more sense to go find your aspects and find the aspects that sort of represent where you're trying to go with your game, to see, especially for UI elements, how that pans out. So I'm going to do a 16:9 aspect, and I think that will work fine enough for me. This is not going to be a full introduction to the game by any means. And I'm going to grab that text and I'm going to move it, I guess, let's do upper right. I'm going to put the word score 0 in it for now. Awesome. And I'm going to also rename this txt score. If we were to play the game right now, we would see this sort of just, it look like this. It'd just be hanging out there at the upper top. There's all sorts of fun things that you can change here for your text if you really want to, right? It can make it sort of a bright yellow if I wanted to. Um, Surprisingly, is that lit? Because that's an awful looking yellow compared to what I chose. Very strange. Oh, you can do an outline. That's fun. Ooh. Learning new things every day. Cool. So now we have that. And space player shooter game. Great. And now we need some place for that number, that 0, to live. So I'm going to go to my scripts folder, and I'm going to right click, and I'm going to create a new C# script, and we'll call this one shooter game. I'm going to let that compile and do its thing. I'm going to double click on shooter game to open that up. And surprise, we're going to use Fusion. And then beneath there, we are going to go ahead and set up a, well, let me open up my cheaters because I know the first thing I'm going to need to do. We're going to go ahead and set up a new public int score. This is going to represent the score in our game. But because it's a network thing, of course, we need to be in a network behavior. Network behavior. And we want to set this up so it's tracking changes to the score. So that when we see a change to the score happen, we update some other piece of the game, say a UI element in this case, or it could be other things as well. To make sure that we respond to that, we're going to tag it with the networked tag. And because it's networked, that means that we can specify what happens when it's changed. So on changed equals name of on score change. So this is our, oh my goodness, there's a phrase for this, but I'm actually forgetting it right now. And this on change needs a capital C for change there. This doesn't exist yet, so we're going to make that in a second. Awesome. So we're going to go right beneath here. We don't actually want the start or the void. Neither of those are useful for us in this script. And we're going to make that first one. So I'm going to make a public space static space void space the name that we just typed in there, that name of on score changed. Open parentheses, close parentheses. I'm going to put something inside those parentheses, but I'm just going to get this like stub finished right here. What's wrong about that? We'll see in a second, I suppose. Inside of on score change, whenever we're doing sort of a listener and a responder to this, we're going to do changed. And then the type of that changed is the shooter game itself. So whatever is the class that we're inside of. And we tend to just call this changed. So what has changed? This has changed. Beautiful. So change shooter game change. Awesome. And I'm going to fill out the rest of this here in a second. So before we get there, we're going to come up because we need a second function. This one is the one that's going to run on all computers when something happens, but we need that something to happen. And we're going to do that here. So public space void space add score. We're going to hard code this to 1. We could soft code this and get some variables in there, but let's make it easy on ourselves because we can only go so far. And we're going to say score is equal to score plus 1. Awesome. So now when this happens, score is changed because this variable that has this tag up here, I don't know why that's mad at me, I'm going to see in a second. Because this variable changed, it's going to invoke this onChange function. So it's going to run this. And what we're going to do down here is update the UI. To be able to update the UI, though, I'm going to need to know about that text field that's on the screen. So I'm going to import something new, TM Pro, which is short for Text Mesh Pro, and I'm going to make another public TMP underscore text, which is short for Text Mesh Pro text. I'm going to call this TXT score. So I'm going to save that. And then down in on score changed, this is a really weird long line of code. I apologize, but we're going to write changed dot behavior dot txt score dot text is equal to changed dot behavior dot score dot to string. Okay. So what this is saying is when this score changes, run this function on every single computer that is running the simulation. Update the text field's text on every single computer to represent that new changed value that we just got. So we're sort of changing the text fields as scores are changing. really useful for us when we need to update these things, these sync pairs here. It's still mad at me about this, and I don't know why. And I wish I could tell why. Flags a property. Networked is not a valid declaration type. Oh, right. Okay. Great, great. Cool. So I know why this is now. So we have this public int score. I came up here and tagged this. For for this type of variable to work, you always have to use a getter and setter. So we're going to put parentheses, curly brackets after score, and we're going to write get colon set colon save. That colon goes. Beautiful. So now we have the setup as a sync var. Um, when the score is changed, it's going to update whatever text field that we told about here to represent that new number. Let's go back to Unity and let's let that compile. Now that that has compiled, we're going to go ahead and make a new empty game object. We're going to call this shooter game. And this is something, it's a strategy that you see quite often. We're going to attach that shooter game to the shooter game script to the shooter game object. We're also going to attach that network object to make sure that it's a networked object. We see this strategy quite often. In fact, I'm going to make a longer script string here inside of my on score change to say score plus whatever. This strategy is called a singleton pattern, which many programmers don't like, but when it comes to making video games, you almost invariably need at least one singleton that represents the game itself. And so this is sort of what we see here. We need some place for the score for the game to live, and we're going to do that by cramming that into the singleton. So there's my shooter game. I've attached the shooter game script to it. I've attached this network object to it. It needs to know about the text to update for this to work. So I'm going to drag txt score from my canvas onto the txt score element for shooter game. Awesome. One last thing has to happen. We need to, at some point, invoke this function to actually change the score in shooter game. To do that, we're going to return to laser. And inside of laser, this is probably where we want the score to go up when you hit an enemy. So right now, when we hit the enemy, we destroy the enemy we hit. We destroy the laser, but we could also tell that shooter game that it's also time to update that score. I'm going to be kind of lazy about this. This is not the ideal way to do it, but it's going to work fine for now. I'm going to use game object's find method. So game object dot find. This is going to search through every single object in your game. It's an expensive call. I don't recommend using it very often. But as always, I'm trying to keep this simple for you. And I named this shooter game. So you want to name this the exact same thing it's named in your hierarchy, shooter game, shooter game. All right, so I've named it shooter game. Dot get component. So we found it. We're going to assume we found it. We're going to get the shooter game script attached to it. So we're going to get that shooter game attached to it. And then we're going to invoke its add score method. Dot add score. So save. So this says, when a laser hits an enemy, go find the shooter game object, get its shooter game script component, and invoke the add score method. We just wrote the add score method that increases the number by 1, but also causes that number to invoke a UI update on all connected clients. So if we run this now, and we cross our fingers and hope that we've configured everything correctly, and we hit start host on this particular client. Oh shit, I need to get rid of that cube still. And we go back and forwards. Uh-oh. My guys need to they need to be split up a little bit here. You're gonna see, however, in addition to these guys sort of flying away, the score up here in the upper right hand corner is going up as I destroy things. I'm kind of interested. Let's just shoot one at a time. So we have 18. We have 19. Okay, good. It's funny. There's only so many ways to actually fix that problem because they're game objects. One actually, no, because this kinematic means that our forces won't work on it. I'm tempted to actually just leave it there for you all. How did I fix that in this version? I'm almost certain what I did was I did the project settings, physics. Did I add an enemy? No. Interesting. That's usually what I do. I think I just made their colliders smaller in this one. Um, how else do I fix that? Let me look at the enemy game object here real fast. Prefabs, enemy, how did I configure you? You have a rigid body, you have a network rigid body, you have a network object, you have an enemy script, you have a box collider. Yeah, I think I just made their colliders smaller than I did in this particular one. So I'll let you customize that one to your purposes moving forward. Goals here, learning outcomes that we're seeking here, the concept of a runner.spawn, the concept of a runner.despawn, this idea of that sync variable, some movement, this idea also of making your own input system and what that looks like. Those are all sort of learning outcomes. Let's do one more thing just for funsies because I hate this Unity skybox so much. I'm going to go to the Unity Asset Store. Boop. Unity Asset Store. Because even in the build I have here, I have a free skybox, so show me free assets. I think this might be the one I have. It might be this one actually. Free stylized skybox, but go find a skybox. Yeah, it's definitely this one. Add to my assets. Maybe not. Open in Unity. How big is this? Open Unity Editor. Am I logged in here? So go find a skybox. Get a free one. 24 megabytes isn't too bad. I'm okay with that. Download that skybox into your project. It's kind of chugging here. Click import once you've done download. You can actually pick and choose if you don't want all of them. I'm just going to import all of them though. Cool. And then once that's imported, it tends to make a folder in your root, which I would recommend moving. I might drop this in materials actually. Oh my goodness. Why are you doing that, Unity? I might drop that into materials. The important thing to note here is that it has some new materials for you, all of these beautiful things. And to get rid of, I'm going to get out of here and go back to my cube and actually delete that cube. Oh, by the way, so to go between canvas mode, so there's canvas mode. I double clicked on the canvas. I hit 2D to see canvas mode. If I hit 2D again, I'll go back into my 3D mode, and I want to double click on something that's down in my world space to return to world space mode. What was I going to do? Oh, right. So last thing to do, the skybox, make it a little bit different. I'm going to go to Window, Rendering, Lighting, Environment, Default Skybox, right there. I click that. I'm going to find one of these other skyboxes. That one's a little sort of depressing, actually. I'm sure it's fine for. Um, I'm kind of digging the sky anime. This like sky low poly night kind of looks nice, though. I'm gonna do that. So now for to play this game, we're not gonna have that default Unity skybox. We're gonna have something that looks a little bit nicer. Start host. And so when we see our game now, right, it looks a little bit more visually engaging because it doesn't look like the default Unity. There's all sorts of other problems here. Now I really want to go and modify my directional light so that, let me add a cube in again real fast. So that the world feels kind of right as well. Okay, one more go, and then we shall wrap this particular one up, and I shall upload these and have you all good to go. Yeah, so now you feel like you're underwater. That's kind of the vibe I'm getting here. Maybe it's not nighttime. Um, this is a good start, however, on we need to fix that, but I'm gonna roll with this for now because it's getting you all the kind of like this. It feels like asteroids wreckage that you're going through. Great. And then all this winds up being networked. So if you run on both, you're good. But I'm gonna let us sort of do that in class. But remember, it's file, build and run both of them. One is host, one is server.